Hi, my name is Angelina Ortiz, and I wanted to start off this explanation video by explaining or defining conservation of energy and the conservation of momentum. So the conservation of energy states that energy can neither be created nor destroyed, but it can be changed from one form into the other or transferred from one object to another. The conservation of momentum is like for a collision between object 1 and 2, usually in an isolated system, that the total momentum of the two objects before the collision is equal to the total momentum of the two objects after the collision. So the momentum that's lost by object 1 is equal to the momentum that is gained by object 2. So concerning my system, I'm mostly focusing on the first couple phases because they all just kind of roll into each other nicely. It's hard to just discuss one single phase. So the momentum of the rolling ball at the very beginning is transferred to the duct tape, which was the next little phase, which is then transferred to the lighter golf ball. Because the smaller ball has a smaller mass than the duct tape before it, it'll move forward with a greater velocity, whereas compared to the velocity of like the ball and the duct tape before it. And furthermore, the duct tape hits the cups that form the tunnel for the golf ball, and there's a transfer of energy there. So there's also that. And overall, these few phases demonstrate the conservation of momentum because the system's total momentum of the objects colliding is conserved, meaning that the momentum has an unchanging value. So concerning conservation of energy, it's also demonstrated in these few steps. Really, conservation of energy and conservation of momentum go hand in hand. But concerning conservation of energy here, we can also see it with the first bigger ball rolling down the ramp and then hitting the duct tape, which is just sitting there stationary. When the ball hits the duct tape, there's a transfer of energy, which then causes the duct tape to move. And although in my system, all the energy from the ball isn't completely put into the duct tape, some energy is transferred, and the ball and the duct tape kind of roll, but there's that. And then the interactions between the duct tape and the golf ball behave similarly to the original ball and the duct tape, in that the duct tape, when it's rolling with its energy and its momentum, it hits the golf ball, therefore transferring energy, causing the ball, to then move. So these couple stages show and demonstrate the conservation of energy, in that they show a change of from potential energy to kinetic energy, or simply the transfer of energy from one object into another. So just kind of like an overall analysis of what is happening with the Rube Goldberg machine in relation to conservation of energy and momentum. If we look at the conservation of energy and conservation of momentum of the system overall, we see that these two laws allow the transfer of energy between objects, which allow for a continual movement forward throughout the entire machine. So that just goes to say that there wasn't a conservation of momentum, like in the very beginning, or a conservation of energy, either if momentum or energy were lost, then say with the first ball that hits the duct tape, there hadn't been a transfer of energy or momentum, then the duct tape wouldn't have moved, which wouldn't have hit the golf ball, therefore disallowing the entire rest of the machine to not really happen. So that's all I have to say. Thank you.